Hello students. With example 3, I want to illustrate to you another application of the diluted concentration formula. In this case, instead of looking at the impact on the concentration of a stream and how it dilutes, we're going to look at the impact on the temperature of a stream and how it's impacted by the mixing. If you remember, according to the lecture, temperature is also a form of pollutant for streams. So let's look at this specific example. You're informed that on February 29, 2013, the stream temperature is 1 degree Celsius, which makes kind of sense. In Ottawa, the Ottawa River is fairly chilly in February, at the end of February. You're then informed that the flow of the Ottawa River on this day is 1950 cubic meters per second. You're then informed that a fictitious nuclear plant, for whatever reason, dumps some warmer water that is used for coolant into the Ottawa River. This wastewater is at 10 degrees Celsius, that is 10 times the temperature of the Ottawa River. Again, fictitious nuclear plant in Ottawa. You're then informed that the flow of this wastewater from the fictitious nuclear plant at 10 degrees Celsius is 5 megaliters per day. So can we calculate what the diluted temperature is then after this 10 times hotter water has had a chance to mix with the Ottawa River in the mixing zone? Can we actually use this formula to calculate the diluted temperature? Obviously, I'm assuming that you figured out by now the answer is yes, and I'll show you how to do it. Before we move forward, just like in example number 2, which you can find here, the units don't quite match in some of these quantities. Specifically, for concentration, same units, degrees Celsius. For flow, not the same units. We have cubic meters per second and megaliters per day. We have a choice. Do we convert from cubic meters per second to megaliters per day or vice versa? I'm going to make a choice, and I choose that I'm going to convert from megaliters per day to cubic meters per second. So both of them will be according to this unit. How do I do that? I remind myself how to go from megaliters to cubic meters as step 1, and from days to seconds in step 2. I don't expect that you would remember these by heart, but given the easy use that you have to wireless technology, your textbooks, a friend, Dr. Google, and so on, you should be able to come up with these conversions fairly easily. Because all of the course material, including your tests and final tests, are online, you also don't have the pressure for this course to come up with this like that. However, please note that that might not be the case once you go in real life. Okay? But for the moment, you're more than welcome to make use of the technology that you have access to. Okay, so somehow I've gone from megaliters to liters, from liters to cubic meters. So that's great. I can convert this unit to this unit. How about from days to seconds? 1 day is 24 hours. 1 hour is 3,600 seconds. The same thing that I mentioned about these units applies to this in terms of the speed at which you're expected to come up with them. Now, I'm going to go through the process of converting this to these units. So if I employ these conversions to convert my waste flow, this is the number I get. 2 out of 3 times. Okay? This cancels out. This cancels out. This stays. This cancels out. And this cancels out. And this stays. So we're left with cubic meters per second. Now to keep things neat and tidy, I'm going to transfer this over here and then erase this precious real estate. Voila. Now I confirmed that everything is in good units. Yes, it looks like. I confirm that I have everything that I need to solve this formula. If I'm looking for diluted concentration, yes. I have each one of these quantities. I can proceed with calculating the answer. Voila. So I plugged everything into my formula. The units all work out. And this is the answer I get. I get that the diluted temperature after dumping some waste in there that is at 10 times the temperature is 1 degree Celsius. Essentially, that translates into saying that there is no effect after the mixing zone on the temperature of the Ottawa River from the wastewater dumped in from this fictitious nuclear plant. So the diluted temperature is unchanged from the original temperature of the river. Does that make sense? Is this a reasonable answer? Well, if we look at it a little closer, it turns out that it is. Although the temperature of the wastewater from the fictitious nuclear plant is 10 times the temperature of the Ottawa River, the flow of that wastewater is almost 36,000 times less than the flow of the Ottawa River. So it turns out this is almost like a figurative drop in the bucket in terms of affecting the Ottawa River. One word of caution though. This is the effect on the Ottawa River, the diluted temperature after the mixing zone. Okay? The temperature closer to this waste and within the mixing zone is somewhere between these two temperatures. So there is probably a greater effect in that area, in the mixing zone. Thank you for your time.